Hi, I'm Jelle.
And I'm Feli.
So there's a lot of ways to create machine learning experiments, but I'm a programmer, and what I would like to do is actually code some machine learning experiments using code. So no having the cloud figure everything out for me, no dragging and dropping. I would like to write some actual code. Is that possible within Azure?
Yes.
Good. I already knew that, but now you know it too. So maybe we should show that, shall we?
Yeah. If you go into the Microsoft Machine Learning workspace, you can see that under Author you have Designer, which we also have a talk about. You have Automated ML, but you also have notebooks. And notebooks are a way to actually write code and really customize your machine learning experience.
So what I know from notebooks is that actually that's not necessarily limited to the cloud, right? Like you can use like Jupyter notebooks anywhere. So this is like the cloud implementation of that idea?
Yeah. So normally you might do some coding like this. You might use Databricks or just Jupyter Notebook, as you said. But what we are going to do is we're using notebooks within the machine learning workspace, but this code will work anywhere. But for us, it's just nice to have it in the machine learning workspace because everything is here and we have our data sets here and all of that, our compute is here.
We're basically connecting everything together and keeping a nice, complete view of everything we're using for our experiments.
Yes. Yeah. So if you want to start a notebook, it's really easy to just go to Samples. And you can see that there are already a lot of samples to work with. And if you have a sample where you think this might sound interesting, for example, the quick start is always a good place to start. There's a get started, but also a way to do AutoML. And you can clone them because these are just the samples, and you can clone them to your own space. And they will appear here, where you can actually edit them and work with them.
So you said that there's ways to do AutoML from within the notebook. So as I understand notebooks, basically you'll have almost complete control over your experiment because you're going to do it programmatically. You can do anything you could be able to do with the automated ML or with the designer. That's all within your control. You just need to be able to, you have to have a bit of a deeper grasp of everything you're doing because you actually have to control everything.
Yeah, and there's still ways to just say, okay, please give me the default options. But if you do something in a notebook, it's easier to replicate later, and it's easier to maybe tweak one little thing and replicate the experiment later. But that's also something that we're going to show you, how you can do that and how you can really use the power of the notebooks.
Let's dive into it.
Yeah, we're going to start with automated ML. And you see that if you download these, if you clone these samples, that they already have a lot of explanation in them. So it really is a great way to start. Even if you don't know 100% what you're doing, they really guide you through it in these notebooks. So we are going to do this one, which is using automated machine learning to predict taxi fares. And we're going to start with this. And
so you've got all these explanatory pieces of text, and then you've got like code snippets that you can execute from within that notebook. Sounds cool. How is it executing that code?
You can see here I already have a compute running, but if you don't already have that, if you try to execute the first piece of code, it will give you a message. Which compute do you want to link it to? And in that case, you can choose a compute. You can stop them here. You can make a new compute, but they are all under computes. And here we
it's-
make a compute instance.
Yeah.
So maybe you can,
Oh, because I see a lot of options here. Yeah.
Yeah.
We've got compute instances and clusters and inference clusters and attached compute. Luckily, I can maybe try to explain the difference because it is kind of important because it's easy to just treat the compute as a black box, but it actually helps if you kind of know which compute you're using and why. So yeah, we had the 4 options, and you see the first option here, which I think is the most easy. A compute instance is basically a single VM, so a virtual machine. It's like someone else has a computer and you're allowed to run your code on that. It's a compute instance, one unity of compute. And you could access such a VM from anywhere, like even using Jupyter notebooks, or if you want to perform some compute within your workspace, a compute instance is the way to go. But you also have compute clusters. So what compute clusters, what makes that different from a compute instance is that it allows you to, a cluster allows you to use one or more nodes in sync, in parallel. So if you have like very intensive tasks that you need to perform that could be like performed in parallel to each other, that's where a compute cluster is much more useful than a compute instance, because you'll have much faster results and the relative costs won't be that much higher. So it's basically free speed. You can always choose between low prio nodes or dedicated nodes. That's also true for the next type of VM that we have, the inference cluster. So if you have low prio nodes, then your nodes may be, let's say, hijacked by anyone else using the cloud, because if they have very important work that they need to be doing, they'll hijack your VMs, your low prio nodes. But if you and that means basically it doesn't mean you lose anything. It doesn't mean your data is unsafe or whatever. It just means you're a little bit slower. If you prioritize speed over cost, you could select dedicated nodes, because then you are certain that those nodes, once you claim them, they're yours, you're going to use them, no one else will touch them. So basically, that also goes for inference clusters, and that's the third category that we have here. But the name already, it will inform you that we're talking about inference here. This is, basically these clusters are more optimized for handling many incoming requests to use model. Basically, if you're talking about the 2 stages, like the training stage of your model and the inference stage, so the production stage of your model, the inference cluster is more useful for that. We have 2 options. That's Azure container instances, which I would say if you're trying to develop or test the utilization of your model, that's what I would use. And of course you have Kubernetes, and if you want actual production value, I would really suggest you go for AKS. Last category of VMs that you can select, or well, in this case, you'll have to connect it, is the attached compute. Basically, if you use any other Azure services that could compute for you, let's say Data Lake or Azure Databricks, or any of those other services that could do some compute in any form for you, you could attach them to your workspace, and they'll show up in your attached compute, and you can select them for any of the tasks that they would work for. And that allows you to really make the workspace the center of your Azure machine learning experience, and that will help anyone developing anyone developing on those experiments to get the experience in one place instead of having it spread out all over the cloud, and you'll have to remember, oh right, we were using Databricks for this. Okay, wait, where do I connect to Databricks? You'll just have a single workspace with everything that you're using. Of course, a final note on those attached computes. Machine learning services, so that workspace, that will keep those VMs that you've created up to date. It will manage it for you. If you attach something, it's up to you to manage it. So connecting attached services has its advantages, but it also has some disadvantages. So yeah, that's basically which types of compute you can select. And of course, yeah, there's if you have a VM, not each VM is the same. So we have basically we have VMs that are optimized for calculation, and basically that are optimized for doing like typical computer stuff. That's CPU. You could maybe think of that as if you're doing something with a smaller model with not that much data. If you're thinking about exploring your data, fine, use some CPU. If you're not sure what to use CPU. It might not be the fastest, but it's definitely going to be the cheapest option available. But if you have like large data sets and you're going to want to do some deep learning and you want to do parallel stuff and you have video images that you're going to process and it's all going to be really, really, really slow, you can optimize the speed by using GPU VMs. So the CPU VMs are in Azure. That's like the DC series, so the VMs which names start with DC something something. That's a CPU compute. Or if you're trying to select like the GPU, I think it's like the NC VMs. That's where you can look around. It'll state it if you try to select a VM. Then there's a final type of compute, FPGA. Basically, that's a field programmable gate array. Very, very cool tech. You can there's a few options in Azure to get such a VM. It's really cool. It's programmable, as it says in the name. So once it's set for something, that's what it's going to do. I wouldn't touch it if you don't know what you're doing. But if you really, really, really need something awesome to really speed up your machine learning experiments, you might investigate whether FPGA is the right option for you. So basically, back to your question, what compute should we use? Yeah, I think you're using the correct one. Yeah.
Yeah. Okay.
So maybe we should continue after that long-winded explanation on compute.
Yeah, so we can just go back to notebooks, and you'll see that I had this notebook to connected to our GPU. So what I was doing, I was looking at taxi fares.
Taxi fares. So are we trying to predict how much it's going to cost us to take a taxi?
Yeah.
Based on what?
Based on a bunch of information. So the first thing I'm going to do is I'm just going to prepare, get all of my packages. You can do that just by clicking Run Cell, or like in most things,
Yeah.
Shift-Enter also works.
So instead of writing the code in this set, we already have the code. We're just going to execute it.
Yeah. And what I would do if I were you, I would just, to start, get some sample code, run all of it, and then kind of see which parts can I tweak to make it work for me. So if I get a different data set, how can I reuse some parts of this code just to kind of learn how it works, and then eventually you can code it yourself. But I always just think it's really nice to get some code that you know is working, check whether it's also working on your machine, and if it does, then you can just try different things and try to tweak a couple of things until it does exactly what you want.
All right, so let's continue predicting taxi fares then.
Yeah, so what I did, I got my all of my packages, and I have a data set that is a data set about taxis. So here I'm just getting our data set. I'm making it into a pandas data frame. Pandas is quite commonly used if you're talking about just general stuff about data. It is just a package with a lot of different ways to filter data, to show data, to do all of these data-related operations. So if I ask for head 10, that just means that I want to see the first 10 things in my data set.
Which, is not necessary, but nice for this demo.
Yeah, so for this demo, it means I can see vendor ID, but also pickup time, drop-off time, passenger count, trip distance, but also all the way at the end, stuff like total amount, tolls amount, tip amount, information about the charges. But yeah, there's a lot of information in here also, where someone was picked up, where someone was dropped off. Just a bunch of information that could be nice to use.
So I would think I could predict that the farther you're driven by your chauffeur, the more it will cost. But there's probably a lot of other factors that play into it as well. And exactly how those would interact, I would have no idea. But we're going to use these notebooks to predict that.
Yeah, so after I've gotten my data, we are now in the data cleaning part of a machine learning solution. We also just need to do basic data cleaning, data changing. For example, we have a pickup time and a drop-off time, but that is not in a format that we can really work with. So we need to make an array with stuff like the month, the day of the week, the hour of the day, all of this extra information that is already in the data set, but not in a format that we can use. After that, we choose to remove a couple of columns like the date time, because we changed the format of that, but also tolls amount, trip type. You can see that, in here it already teaches you how to do all of that.
Yeah, mostly this is because this is a nice demo to show how it would be done. Because if you already know what kind of column you're interested in, you're gonna have to do this step anyway.
Yeah.
But you would not know this if you did not know your data set quite well. So it's good that it shows us how to do it, and it also shows us that it's really important, again, to always study the data that you have.
Yeah, so for example, in this case, we want to specify that our data set, we only want to know how it is with taxi prices in the Manhattan area. So we need to, anything with another pickup, anything with another pickup point needs to be removed. And this really shows you that there are a lot of steps that you need to do before you can actually use your data. And it's really important to always look at your data and possibly clean your data before you can actually go and use it.
Good to know that you can do it in multiple ways, but programmatically is a very, to me as a programmer, it feels a very safe way to handle data. Just write out what you're changing.
Yeah. And now that we have our final data set that we want to use, we can start working on the actual machine learning related stuff. So the first thing that we do is we import workspace. So we have an existing workspace, but now we just want to make a workspace object from that. And after we've done that, it is now linked to the workspace and we can work with it. So we split the data into train, into test, which we've talked before about kind of the 5 steps of machine learning, which is choose your data, clean your data, split the data into training, into testing, apply the model or train the model, and then evaluate and score. So here we're going to do the third step, which is splitting it into training and testing. And it is actually really nice if you just hover over something. It already shows you all of the options. So if you hover over here, you can already see what kind of input it wants, what kind of output you're getting.
If you're familiar with like Visual Studio or Visual Studio Code, you have this IntelliSense kind of thing. That's basically what we have here, but it's because it's there's a lot to untangle. The IntelliSense is also really, really expansive, and there's a lot of things to uncover.
Yeah, yeah. So now we are going into the AutoML, because the next step is actually applying the model, training the model. So now we're actually going to do the AutoML stuff.
So we're not going to choose an algorithm. We're just going to say, here's a bunch of algorithms. You figure it out.
Yeah, and what you can see here is that there are quite a lot of training settings that we also have in the automated ML that we can also see here. For example, the timeout in minutes, the primary metric, number of cross-validations. These are all stuff that you can also apply if you click here on automated ML, but this is also possible to do in the code. And if you have all of these settings, you can send them here in the AutoML config. And after that, you can train the automatic regression model. And you see, if you run this,
I would expect that to take a while.
That takes a while. And basically, after you've run this, I've already done this part before so that we can see what happens afterwards. But yeah, it will run. You will get a bunch of information, and this is a widget that you can get, and it shows you how your run is going. So then, once your run is completed, this widget will say so, and you can continue going.
And it's using all the storages that we've configured for the workspace to actually store all those results.
Yes. After we've done that, we can now get the best model, because we have our local run, and from there we can get the best run and the fitted model. Mm-hmm. And if we run that, I'm not going to run it now because then I'm losing my previous progress. But if we do that now, we can see what is the experiment, what is the status, but also with the pipeline that we have, what did it do, and just what is the best fitted model, and what information are we getting out of there?
Are we happy with the fit of the model, or is it still not good enough? What can we change? What's the problems that it's having?
Yeah, and this one just gives you the information about the model, and then if you want to actually predict the accuracy, because this one gives you the model and the information about the model, but not all of the scores yet. Mm-hmm. For that, we can use predict, so we can use the fitted model and predict that on a certain set.
Only now could we find out how well the model is actually doing.
Yes.
Based on the split data that we split before, we have the...
Now we can decide how our model is doing, and from there on we can see that we get a bunch of predictions. In other talks that we did, we mostly talked about regression. No, we mostly talked about classification algorithms.
I was going to correct you, but yes.
But this is regression, because here we are getting numbers, which means that we can't actually get back an accuracy. So we need to look at stuff like the root mean squared error to get our results and see how well our algorithm is doing.
Again, if you're now thinking, oh no, math, good luck, because machine learning is a lot of math, and you'll need it.
I think what you need to know with the root mean squared error is lower is better. So with accuracy is between 0 and 1, and higher is better, but mean root square error is between 0 and infinity, and 0 is better.
And infinity is not so good.
Yeah. But you can also see that there's a lot of packages that you can just use, which makes it really easy to get all of these information. So you don't always have to know exactly
So
Like what? Yeah.
not only do I have total control because I am coding, I can still be lazy and import a lot of packages and have
Yes.
someone else who I trust to have done this correctly do all the work for me,
Yes.
as a programmer should. Yeah.
Yeah, so basically you can use that to eventually get your, some kind of accuracy, and this will give you a result. So this will give you a result, and then later on you might want to choose a different algorithm and do the same thing and see if it gives different results. But this kind of shows you how easy it is to just get a notebook from the samples, clone that to your own files, and then just see what happens if you run it, and see what happens if you change a couple of things. And that's a really good way to kind of learn about machine learning and learn about the different settings that there are without getting completely lost within all of the different options that you get with all of the different packages.
So I'd say that the notebooks are probably the most powerful and the most the way that you want to go if you want to have a lot of control over exactly what's happening. But the designer or AutomateML both also have their pluses and their pros and cons that you could choose instead. If you like coding, then the notebook is, of course, that's the fun way to do it. But that doesn't mean that it's necessarily the best way for you to go. And I would really suggest getting familiar with all three of these authoring options.
Yeah, and I think it's what we did right now, we could also do within AutomateML. So if you just have like a basic problem that you need solving, you can always start somewhere and then kind of move your way down. Because I think if you don't need all of these options, it's also fine to just use AutomateML. There's nothing wrong with using AutomateML or using the designer if you don't need all of these extra options that Notebooks gives you.
All right. So maybe we should end on a book recommendation.
Yes. So
because I've selected a very nice book that I think, if you're only slightly interested in chess but very interested in AI, this might be the book for you. If you don't know the name Garry Kasparov, then you do now. He's like this really famous chess player. I really think you should know him. And he wrote a book about what, unfortunately for him, he has become most famous for, and that's losing to chess AI, to Deep Blue. He wrote a book about that. It both goes into the game and what he thinks of that, and but it also goes. He also goes to continue and tries to figure out what this means for the future, both in chess but also more broadly for life. What AI might do to change, basically how we live and interact and game. It's a really good read, and I deeply recommend it. Deep thinking. Yeah. Okay. I think that's it, right?
that's
We're done. Hope you enjoyed. Thank you very much.
Bye.
All right.